In this session, we'll be discussing about basics of time series. So, time series is one of the very important forecasting techniques used in the industry as well as in the statistical world. So, forecasting is one of the most important and frequently addressed problem in analytics. Inaccurate forecasting can give a significant impact on the both top line and bottom line of any organization. So, for example, in any organization, a non-availability of a product in the market can result in a customer dissatisfaction. So always organizations have to like focus their inventories and demand, and they have to work accordingly. So too much of inventory can erode the organization's profit. So it becomes very necessary for any organization to focus the demand for the product and service as accurately as possible to maximize their revenue. Okay, so it is one of the very important and frequently used application in predictive analytics. Okay, so every organization prepares a long range or short range plan for forecasting demand for a product or a service. Okay, so different capacity planning problems are like is using time series concepts. For example, we have manpower planning, planning mission capacity, warehouse capacity, material requirement planning. These are like the problems the production department face. Whereas in the marketing and sales, they actually like predict the demand for the product, and they focus sales. So everything that happens in the marketing department. So all functions of a business uses time series. So budget allocation for marketing promotions and advertisements, actually it's part of the finance department. So they also use forecasting techniques. So but this forecasting can be very challenging due to a lot of factors. Okay, but still organizations undergo this method to find out what's going to happen in the future. So there are a lot of organizations like follow time series to forecast. For example, I think everybody know about Boeing. So Boeing aircraft has more than 6 million parts. Okay, and there are a lot of thousands of unique parts they have. So forecasting demand for this spare part is very important, because if non-availability of the critical parts can result in the aircraft malfunction, or uh, it will be like out of service. So it is like very expensive for any airlines. Okay, so time series is very useful in predicting the demand for the or the usage of spare parts for any aircraft, especially in Boeing. In Amazon, they said more than 500 million products right now through their portal. So predicting demand for these products is very important, because overstocking can lead to loss, whereas like understocking can result in customer dissatisfaction. So even if they have to like predict the products, they have to do it right to maximize their revenue. And this applies for any store like Walmart or Reliance, whatever store, retail store you take, they have to correctly predict their products to be stocked. Otherwise they might go out of sale. Okay, so now I think you understand why time series is like very important in any organization. So what is this time series actually? So it's nothing but a set of statistical observations arranged in the right order. For example, imagine I'm a company who is like kind of selling my products, any product. Okay, so I have been in the operation for 10 years. So I'm arranging my sales per annum according to the order from top to bottom in chronological order. Or maybe I can say I started the company in 2011. So from 2011, I have a sales of like some number. 2012, I have some number. So I'm arranging this. And when you do that, you can say your data is following the time series order. Okay, so there's a lot of definitions available. So if you can just like give a right sense of what time series is, that's fine. You can quote any definition. So time series is nothing but a set of statistical observation arranged in a chronological order, or a time series is an observed phenomenon recorded at successive points of time. So earlier I mentioned the sales recorded at each year. So it can be each week, it can be like each month, but the time the recorded should be in the right intervals, equal intervals. Okay, so this is like applied in a lot of places, as I told you before. So time series is applied in science, engineering, commerce, wherever you can able to measure a variable time. Okay, so that is like it's done everywhere. Even in education, you can measure performance of a student over a period of time. You can measure how a product is doing over a period of time. You can measure how a stock is doing over a period of time. So it's every time when you measure variable over a period of time, you can apply series on that. Okay, so for example, I've listed a few examples here. So reserve banks, they always like they has a they are the regulatory authority of maintaining interest rates. So when you record the interest rates over a period of time, you can predict what is the interest rate going to be in the future. And foreign exchange, yet there's a fluctuation always, right? So you can record the data of foreign exchange every day, and in the company you can record the production sales per week or per month according to the need. It has been applied in a lot of places in budget. So we have just got a budget released recently for our country. So how do they predict what is the money that they need for each of the industry? So how do they do it? They apply time series techniques. In financial marketing analysis, in predicting the stock price, people use time series. In census, so always you say, okay, population of India is so and so, and over a period of time, we expect that to increase to an extent, and we have a growth rate, right? And we have a death rate, an expected death rate and growth rate. How it is all calculated? This is calculated majorly because of the time series and inventory management. We just discussed about it. So any organization has to maintain the inventory right to maximize the profits. Otherwise, they might be stocking more and paying the warehouse more. Otherwise, imagine if you are have products which are very perishable. In that case, you really end up in loss. In economic forecasting, yes. So people figure out what is the GDP is going to be in the next year, right? So all this is done based on time series. Marketing and sales forecasting, just now we discussed, right? And yield projections, which means like in agriculture, what happens in the future, how much my country will be able to produce next year, whether we'll be able to provide for the whole population. This is predicted by the government through time series. Seismological predictions, I mean this for earthquake. So people might say, okay, we might be expecting a earthquake in the next 6 hours, or you might be expecting a rain in next few days. So how this is all done? It's all based on the time series forecasting and workload projections. In HR, they use in time series too. In workforce management, in militaries, yes, it has been used in positioning the soldiers and the military equipments. Okay, so here I have a small data set to show you how the time series data looks like. So I've been talking about the year in sales. Here I have just a price of particular product in the year 1970. It was $180. In 1972, it is $200. And over a period of time, in 1982, it has become $560. Okay, when you see data here, the year, it is not a random data. So it's all you have interval of 2 points. Okay, from 1970 to 1972, we have like 2-point interval. Until the whole data, we have a 2-point interval. So we can say we have a equidistant points of time. Okay, so always the time interval should be constant and equal. Otherwise, it will not be considered the time series data. Okay, so it can be like yearly, monthly, weekly, hourly, daily. It can be anything, but you should be able to measure a variable over a period of time. When you do that, you can call that as a time series data. Okay, so there are various components of time series here. Okay, so over a period of time, you have to measure your time series data. So to measure your time series data, you have to consider these 4 components. They are trend, seasonal variation, cyclic variation, irregular variation. So we will be discussing about these 4 components of time series right now. Okay. So trend or secular trend. So what is this trend? So usually, when we see a data over a period of time, we see there is a gradual change. So sometimes it will gradually increase, or sometimes it's gradually decrease. So when I show you the previous data here, over a period of time here from 1970 to 1982, so here the price of the product is kind of increasing, and then it's kind of decreasing down, and then it's increasing. Okay, so you can't just say there's a secular trend, but you can say we can have the data for some other example, but when you say a secular trend over a period of time, when the data will be like kind of either increasing constantly or decreasing constantly. A very few example is like the rates of gold. So when you see in India, you take any place in the world, the gold rate is kind of increasing over a period of time. It is not decreasing. And the price of land and the technological advancement, yes. Growth of population, yes, it is increasing always. So you have a few examples here. So population of a country is always an upward trend. The increase of price of gold rate is always an upward trend, whereas your death rate is kind of increasing because your technology, your medical technology is advancing. So then the death rate is decreasing. So because of a root cause, because of a root cause, you might see either a decrease in your trend or an increase in your trend. Okay, so because of technological advancement, we can see the death rate is decreasing. So here we have a small example for this. So we have the years and price of a product one, price of a product two. So over a period of year from 1991 to 2009, you see the prices increasing. So here you can see the graph here. So x-axis has the years and y-axis has the price. So when you plot the numbers, you see the graph is kind of increasing over a period of year. Whereas when you plot the price of the product two, the price is decreasing. Okay, so maybe we can just say because of the technological advancement, one of the product price is increasing, and maybe like due to the less usage of a particular product, the price of a product is decreasing. There should be some root cause, or there might be mass production. That's why this price of product is decreasing. Okay, and in here, due to the depletion of natural resources, the price of the product might be increasing. For example, gold, because it's a natural resource and there's only like so much gold in the whole world. You can't like create gold like artificially as of right now. So obviously it's going to increase. And the price of land. So in Earth, we just have enough land. This natural resource is not going to increase. So obviously the price is going to increase forever, right? Your fossil fuels, everything falls into that category. And for the price too, maybe we can say the price of electronic gadgets and everything, it's kind of decreasing. I'm talking about only few gadgets. So here the price is decreasing because of the mass production. Next one is seasonal variation. Okay, in some of the time series data, you can see there is a variation happening, but this variation is always kind of repeating over a period of time. Okay, you can see sales of an ice cream. So when you see, it is not always growing, or it's not always decreasing. So sales of ice cream increases during winter and decreases during, sorry, the sale of ice cream increases during summer and decreases during winter, right? So it may be, so it can, the root cause can be any. So if you see a periodic variation in your data due to any of the root cause like weather conditions or like behavior of people, you can see the variation. You can call it as a seasonal variation. So this variation is predictable. Okay, so you can say always the sale of an umbrella will always increase during rainy season, right? So you have a small data here over a period of mm, months from Jan to December, and sales of umbrella in one of the shop. Okay, in January, the shop sold 20 umbrellas, whereas in September it was like around 60. So maybe we can say from June to October, sales is kind of at its peak. When you see, when you plot that in the graph, you can see that. So you can say September is actually the rainy season. So the rains kind of started in June and then got into max in September and started declining from October, from September, after September. Okay. So third component is cyclic variation. So this is a variation which happens in most of the businesses. Okay. So or in any country or in any person's life. It's a cycle. For example, a person might be, or a country or a company might be doing well first, and then the performance decrease, and the performance will go very bad, and then they will recover, and then they'll start doing again. So this happens for any country. It happens for any business. Okay, so you can call that these stages as prosperity, recession, depression, and recovery. So I can just show you a small graph for this. So when your sale for a particular, when your revenue for a particular company is kind of increasing, so you can say you're in a prosperity stage, but your sales is always kind of decreasing for a period of time. So you get into a recession, and it's kind of like going down beyond a point. So when you're in loss, your GDP is negative, so that is your depression stage. And then over a period of time, you work hard and you recover everything and come back to a normal stage. So this is your recovery stage. So this is a cycle which happens in any organization, any country. And right now, during this pandemic times, most of the companies are like going to recession and depression, as well as most of the countries. GDP is kind of negative right now, apart from very few countries. So this is kind of normal. Even when you say we consider USA as one of the powerful countries in the world, even they went through depression. In 1930s, they went into depression, and later in 2000s, they had around 2000s they had a depression. In 2010, they had a depression, and right now, due to COVID time, every country is getting into a recession stage. So it's common. So whenever there is a fall, there's always a high. So it's a cycle that everybody goes through. So time series is able to capture that component. And fourth one is irregular variation. So earlier we saw variation happening due to season or sometimes because of the cycle, business cycle. But here sometimes you expect a you undergo an unexpected variation. So you never thought that you'll be able to went into this. For example, this COVID-19 is one of the COVID-19 is one of the very bad stage for all this. And because of this unexpected happening, what happened? So a lot of businesses went into loss, right? So you can call this as an irregular variation. So another example is like increase in the price of vegetables due to a strike of lorries or railway workers, or increase in the number of deaths due to earthquake, or an increase in the number of deaths. Usually we might have having a graph, and maybe due to COVID, the graph might just go up in India or in the state, right? So this is an irregular variation. It is kind of a sudden unexpected variation, which is not like expected by any of them. Okay, so these are the four components that any of the time series data will have. So it is very important to capture all these variations in your data to predict the future rightly. So an analytical study of all these different components is called as time series analysis. So how do you calculate the or predict the future trend based on your past data? So there's a lot of methods available. First one is graphical method. So in this method, you just like plot your data as I've shown you before in the examples, and then from there you will able to like predict the future. That is in graphical method. Second one is method of semi-average, where you'll be like calculating a semi-average. You'll be dividing your data into two halves and then calculate the average for both the two halves, and then you find out the difference and then accordingly work on that. So that is a semi-average method. So in the third method of moving average, so you will be able to find an average, moving average for two observations or three observations, and then you find out an average, and then you calculate and find what is the predicted value. And next is a very popular method of using regression, which is a method of least squares, where it is used to like find any type of trend, a linear trend, quadratic trend, or exponential trend. Okay, so I believe you have already discussed about this different methods of measuring trends. Okay, so I'll be sharing some of the examples for this and problems to work out after the session. Okay, so we have another method to find out the individual component of time series. So this is called decomposition method. Okay, so in this decomposition method, it's based on two basic models. First one is additive and multiplicative. So in the additive model, you just sum up all the four components of time series analysis. We just discussed trend, seasonal, cyclic, and random. So when you say random, it's your irregular variation. So you just sum up all the four and then get your additive model. Whereas when you multiply all these four components, you call that as a multiplicative model. So you can't just use additive and multiplicative randomly. So multiplicative model is perform well when you see a seasonal variation is kind of increasing over a period of time. So here you see there is a seasonal variation, but this seasonal variation is kind of increasing. The sale is increasing, but over a period of time with seasonal variation. So during this time, you have to go for a multiplicative model, whereas in the additive model, here you have a constant graph. So you have a seasonal variation, but it's kind of not increasing much. So here the variation is kind of little constant over a period of time when compared to previous graph. So in during this situation, you have to go for additive model. Okay, the formula for additive decomposition method is trend at a period of time t plus seasonal component of a time t plus C, a cyclic component of time t, plus I, an irregular component of time t. Okay, so this is your additive decomposition model. Next one is your multiplicative decomposition model. Here you'll just do a product of all the four components. Okay, to find your time series value. Why? Okay. So I believe you got a better understanding of this additive and multiplicative model. So far we have been discussing about what is time series and how it has been applied in different industries and what is the real purpose of using time series. So we just discussed the governments use time series, companies use time series methods to predict their future, and we discussed what are the different components of time series and models to compute time series value. If you got any questions, you can ask right now.